Hello there. We're going to do a short little mini lesson on independent and dependent probability. So let's start with independent. Independent probability, the Webster definition here is when two events are said to be independent of each other. What this means is that probability that one event occur in no way affects the probability of the other event occurring. So, for example, it's going to be like flipping a coin. Whenever you flip a coin, you can either get heads or tails. And then the next time you flip a coin, once again, it's only heads or tail. And then in the grand scheme of things, if you were to flip a coin 1,000 times, you're still going to have about a 50% chance that it will be 50% would have been heads and 50% would have been tails. And if it wasn't, then if you were to keep on flipping, eventually it would be exactly even because that is probability. Or drawing a marble and putting it back. This is very important. They had to put it back because otherwise that would be affecting each other. Because if you didn't put it back, that would change what the probability was. And another example is the probability of there being a sunny day and a pop quiz. See, the probability of there being a sunny day and the probability of there being a pop quiz have no relation to each other. There's no way that if there's a sunny day that there's also going to be a pop quiz, except maybe if the pop quiz was about rain or something like that. But in general, these are not going to affect each other. So let's start with a bit of an example here. So let's say we draw 3 marbles from a bag with a total of 9 marbles in them. 4 are going to be red, 2 will be green, and 3 will be yellow. But every time you draw a marble, you put it back in the bag. So let's say we were to draw we drew all the yellow ones. Let's say we drew 3 yellow ones. So our first chance, because we have a 1, we have a 3 actually out of 9 chance of drawing a yellow marble the first time, or 1/3. So if we were to draw a yellow marble the first time, there was a 1/3 chance or 33% chance that we were going to draw a yellow marble. Okay, and then we put that marble back. So now we have another 1/3. So here's our first 1/3. But now we're going to draw another marble, and that one ends up being a yellow again. So once again, we had a 1 chance of drawing that. So now we have another 1/3 here, 1/3 chance of drawing that. And then we put that marble back and we draw another marble again. This time the marble is all again yellow. So we have another 1/3 chance here. And then how we'd actually find the probability of this happening is we would take each one of these 1/3s and we would multiply it by each other. So multiplication, you do 1 times 1 times 1 because these have all the same denominators. So we can just multiply straight across to get 1 on the top. And then we get 3 cubed on the bottom because we have 3 times 3 times 3. So that is going to be equal to 1/27th because 3 times 3 is 9 times 3 is 27. So that is the probability of picking the 3 yellow marbles with replacement 3. So let's do another one. So here we have, like this one we had up here, the probability of being a sunny day and a pop quiz on the same day. So we know there's a 50% chance that there's a rain tomorrow. And we know that your teacher was messing with you the day before and said that there was going to be a 33% chance of having a probability quiz because right now you're learning about probability in your class. So there's a 33 and a 50% chance. So let's put that into fractions. 50% is 1/2. There's a 1/2 chance that it is going to rain tomorrow, or that it is not going to rain, depending on if you're half cup empty or half cup full. And then you have a 1/3 chance of having a test tomorrow. So like we're going to see the probability of having both today on the same day. So that's going to be tomorrow. That's the only information we have. So we're just going to take them times each other to get the probability. So 1 times 1 is 1, and 2 times 3 is 6, because that's how we do fractions multiplication. So we have 1/6. There's a 1/6 probability of there being both for it to rain tomorrow and for you to have a pop quiz. And then also, if we were to figure out the other way, what's the chances of not having a pop quiz tomorrow? So we'd have 2/3 times 1/2. Okay, and that can be the chances that it will rain and not rain because it's 50%. So that is essentially going to be 6/2 or a 1/3. So there's a 1/3 chance of there not being a quiz tomorrow and for it to rain. Okay, so now let's move on to dependent. So the definition of dependent is two events are dependent if the outcome or occurrence of the first event affects the outcome of the second event. So that's saying that the probability has changed from this one. So let's use that marble example that we had because this is a very good example. So with that marble, in the first problem, we put the marble back. So that way it didn't change what we were doing. But this time, this is without replacement right here. This says without replacement. So that means that you are going to keep that marble. So anytime when you draw that marble back out, you're going to not put it back in. Okay, so we also have drawing a deck of cards. This one's pretty interesting too because there's only so many cards in a whole set. And if a magician comes up and asks you that he wants you to draw a card, you have a 4 out of 52 chance to select a certain number of a certain suit. And then we have flipping a fair coin in a certain order. So that's going to be like if somebody had said, hey, what's the probability of flipping 2 heads in a row if you only flip the coin 4 times? And that would be another example of that. Because now, unlike in the first example up there in independent, it's when you find a certain order. And that's actually going to affect each other. Because if you have heads, because in that first one you can have heads, 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 and heads, or you can have heads, 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 tails, or heads, 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 tails, heads, heads, tails, or heads, tails, 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 and all these different ways are going to affect each other because you only want one of the certain ways. So let's do an example now. We're actually going to start with that same example that we had up there about the marbles. So you have the 3 marbles, and you're going to draw 3 marbles from a bag with 9 marbles. Same amount, 4 red, 2 green, 3 yellow. But instead, this time, you're going to keep it. So keeping the marbles this time. So this time you keep the marbles. So let's figure that out. So the first time, once again, we're going to be trying to find if we were to draw all 3 of the yellow. So the first time there is a 3 out of 9 chance. And we're actually not going to simplify this so that we can see the progression of this. So first time there's 3 out of 9 chance that we would select that first yellow marbles. And then the second time, there's only 2 marbles now. And because we also drew because we drew one of the yellow, but since we also took that yellow, there's only a total of 8 marbles. There's only 8 marbles now in the bag, and we draw a yellow, but there's only 2 yellow, so our probability of getting that yellow was 2/8. Then our probability would then change again because now there's only 7 marbles in the whole bag, and we draw the last yellow marble, so there is only 1. So now we have 3 times 2 times 1, so that is going to be 6. And we have 9 times 8, and 9 times 8 is 72, and 72 times, 1 second, 72 times 7 is 504. So this is going to be over 504. So just a recap on the difference here, that we have independent and dependent variables. Well, probability, I mean. And independent is going to be when the 2 probabilities of something do not affect each other. They're independent of each other. So this one, because it's an independent thing on all by itself, does not affect it at all. And the dependent is going to be when they do affect each other. So I'm going to draw a little example to help keep that in mind. Let's say we have a family here. Your mom and your father are independent of each other because they can support one each other. They're both independent people. But according to government and law, the children that would be you and so you and your brother. I'm gonna put B for brother. You are dependent. So you are dependent on them. So if you can just kind of think of it like that your mother and father are independent, and then think about how in probability each of the probabilities are independent, so they don't affect one another. Whereas you and your brother are dependent. You're dependent on your parents for money and a place to live and something to eat. So you are dependent. So you affect one another, like in dependent probability. Okay. Thank you for watching, and just comment if you have a certain video you'd like me to make.